All right, lesson 4-5. And today we're going to do graphs of the other 4 trig functions. So tangent, cotangent, cosecant, and secant. All of them. You're like, whoa, that's a lot. Cotangent and tangent are going to be the tough ones, like with new stuff. But secant and cosecant, if you're comfortable with sine and cosine, they're actually really easy. Okay. Okay, let's start with tangent. Here we go. Y equals tangent x. All right, so let's graph tangent. Now, as you know from the unit circle, we know that tangent can be undefined. Okay? So we also know from the unit circle that tangent is the y over the x value, which is the sine over the cosine value. And so anytime that cosine of x is equal to 0, tangent is undefined. Okay? So think about, not on the unit circle, but think about on the graph of cosine. Think about where cosine hits 0, right? So cosine, if you go 1, 2, 3, 4, 2 pi, pi over 2, 3 pi over 2. And if you graph the basic cosine, you guys should be pretty good at just graphing this real quickly, your parent function. So you would go here, down to there, back to there, up to here. Okay? And so as you see, cosine hits 0 right here at negative pi over 2. Cosine is 0 at positive pi over 2. So negative pi over 2, positive pi over 2. It's also back to 0 at 3 pi over 2. What do you think the next one would be? No guesses? It's all the odd pi over 2s. So the next one would be 5 pi over 2. That would be this point right here. Okay? So at all of the odd pi over 2s, tangent, or cosine is 0. So tangent would be undefined there. All right, so what's going to happen is you're going to get asymptotes. So let's go ahead and let's graph y equals tangent x. And I'll just show you the graph, the parent graph of it, and then we'll do a bunch of stuff by shifting it, reflecting it, doing all the things. Okay, here we go. So since tangent is undefined at all of those spots, we are going to have, for basic tangent, you're going to have asymptotes at, they call it x equals k times pi over 2, where k is an odd integer. K is an odd integer. So all the odd integers for pi over 2. What was that?
A bird just ran the window.
Oh,
Flew away, though.
that's really sad. Okay, so here's what we do. We go to pi over 2, and we go to negative pi over 2, and you're going to draw asymptotes there, vertical asymptotes. Okay. And then this would be pi. Pi's fine. But then 3 pi over 2, which is an odd pi over 2, would have an asymptote also. Now, here we go. We're going to actually graph tangent. So tangent, the graph of tangent will go through 0, 0, because, if we have sine over cosine, it's going to be sine is 0 over 1, so it'd be 0. And this is what it looks like. It's going to, the basic one is going to be at 1, at pi over 4, tangent is equal to 1, right? Think about the unit circle. At pi over 4, sine and cosine are both rad 2 over 2. Tangent is 1 there. And then at negative pi over 4, tangent is negative 1. And so the graph of tangent is going to look a lot like a cubic function, like y equals x cubed. but there's an infinite amount of them. It keeps repeating itself. Okay? And it would go over here, and it would do it again. All right? And so let's talk about this graph real quick. Here are some interesting things about tangent. The domain of tangent is going to be all reals except at all those asymptotes. So all reals except for at the, and they do this, k times pi over 2, and k is odd. Such a gross way to write it, huh? So all the asymptotes. The range, what's the range of tangent? The range of tangent is all real numbers. Or you can say negative infinity to infinity. Okay. This graph is constantly increasing. As you jump on it right here and you keep going up, it's just constantly increasing, never decreases. There's no local extreme values. There's no maximum or minimums. What else? It's symmetric over the origin, so it's an odd function. And that's about it. Oh, the period. Let's talk about period. The period of tangent, one full period is where you have one of these guys. Okay? One of those guys is happening between negative pi over 2 and pi over 2. How much is that? What's that span there? Someone said it? It's just pi. So the period of tangent is pi. When the period of sine and cosine is 2 pi, the period of tangent is just pi. And I ask you for 2 periods of it. I want to see 2 of these, okay? You don't have to draw the third one. But when you're doing tangent and cotangent, I need to see 2 full periods of it. Okay. There's no amplitude. So there's no amplitude. We will get some stretches, though. We'll get some stretches by putting a number out front, but that number is not the amplitude. We'll also get some shifts left and right. Okay? All right, so let me go ahead and tell you a nice, easy way to graph all of these tangents coming up. Here's the trick. What you're going to do is this. To find the asymptotes, it's something that you can memorize. You're going to do plus or minus pi over 2 divided by b. Okay? And that's going to be the kind of trick, the key to graphing tangent if you like to memorize stuff. If not, then you'll have to think of where cosine is undefined, or cosine is 0, which makes tangent undefined. Yeah, because tangent can be y equals a tangent of bx. So it's going to have a number in front of x, which is going to change its period, which changes its asymptotes. All right, so let's do one. Let's do one that's different than just regular tangent. So here we go. Number 1. Y equals tangent of x over 2. Y equals tangent of x over 2. Okay, so here we go. This is how I start by graphing these, especially if I've memorized that plus or minus pi over 2. So I would say that my asymptotes are going to be at plus or minus pi over 2 divided by b. And what's b in this case? 1/2. Perfect. Flip it, multiply. My asymptotes are going to be at x equals plus or minus pi. Okay? So I'm going to go to my graph, and here we go. The asymptotes are so helpful. They're going to tell you all you need to know. So go over here to negative pi, and go over here to positive pi. Okay? And draw your asymptotes. And that's going to be one full period of tangent in there. All right, but I told you you have to do 2. So here's how you do the second one. So this would be 0, right? This is 1 pi, 2 pi, 3 pi is going to be our other asymptote. Okay? Because see this? You have negative pi as an asymptote, you have something in the middle, then you have pi as an asymptote. So I need something in the middle and then 3 pi. I kind of spread it out a little bit too much, but you get the idea. And I need to see what these asymptotes are. Okay? And then you just graph basic tangent. Nothing else has changed. It hasn't been stretched or shifted or anything. So tangent will go through 0, 0, It'll go like this, okay? If you want to be like more accurate, you could say this is 1 and this is pi over 2. But I don't really need that unless that changes. I'll show you how to do that. And then graph 2 of them. Okay, pretty good? So the asymptotes are going to be the most helpful thing in doing these. All right, let's do one now where it gets stretched and reflected. And the asymptotes change. I'll throw them all out there. Not all of it yet. All right, y equals -3 tangent of 2x. -3 tangent of 2x. Okay, here we go. Start by finding the asymptotes. The asymptotes are going to be at plus or minus pi over 2. Always start with basic tangent asymptotes, which are at plus or minus pi over 2, because that's where cosine is 0. And then divide that by 2. So what's half of plus or minus pi over 2? That would be plus or minus pi over 4. Everything's getting all shrink down now. All right, so let's go to our graph and let's graph our asymptotes. And then I'll tell you how that -3 is affecting our graph too. So go here to pi over 4 and negative pi over 4. And draw your asymptotes in. And if you have other ways that you prefer to graph these, I have no problem with that, okay? I try to do like the easiest way for you to do them without memorizing stuff most of the time. In this case, we had to memorize a little something. Okay, so this would be 0. This is 1 pi over 4. This is 2 pi over 4. So that would make my next asymptote at 3 pi over 4. I need you to label that, okay? Just count. 1 pi over 4. 2 pi over 4 is going to be where it goes through. Because that's what people will do. They'll think there's another asymptote right here, but there's not. See this? What's the period here? What's the whole thing? Negative pi over 4 to pi over 4 is pi over 2. So I need to go another distance of pi over 2 to get to the next one. All right, so how does that -3 affect us? I'll show you. Count 1, 2, 3, and 1, 2, -3. What this is going to do is tangent's still going to go through the origin, but the -3 is going to flip everything. It actually flips everything over the x-axis. So normally when I'm up here at 3, I'm going to be down here at -3, halfway between. And normally when I'm here at -1, halfway between, I'm up here at +3. So what it does is it stretches it out, and it flips it too. Okay, so it looks like a negative cubic, right? Negative cubes do that. Real skinny, like that. Pretty good? Yeah.
For the first one, we're obviously going to have to do, like, label it 3, but the second one, can we just draw it?
Yeah. Yeah, I'm fine with that. Because you could go like that. But I mostly look at this when I'm grading these. I'll look to see if these are accurate points, and then I also look to see if you've labeled the other asymptote. And then you draw 2 of them. Yep, just 2. All right, let's shift it now. Shifting stinks, but we'll do it. Here we go. Number 3, and then we'll move on to cotangent after that. Okay, number 3, let's do a shift of, let's do y equals 2 tangent of x minus pi over 2. 2 tangent, it's cold in here. Are you guys cold? Yeah? Okay, I'll fix that in just a second. All right, so here we go. First of all, our asymptotes are going to be at plus or minus pi over 2 over b, and b in this case is 1. So our asymptotes are at plus or minus pi over 2, but they're not though. They're not. Because for this graph, everything is getting shifted. Oh. It's getting shifted pi over 2. Does it matter? Are you back to normal? No, you're not. Okay, good. Phew. Yeah, sometimes I do that. I'll do a shift and it'll be like you're shifted right back to the same graph. Okay, so here we go. Normally, my graph would be a shift at, or an asymptote through here at pi over 2 and negative pi over 2. But I need to shift everything pi over 2 to the right. Okay, So this asymptote that would have been here is really going over to here now. Okay? And I don't even like to draw these asymptotes in. I drew it in red. I'm going to erase it because it's so confusing when you have like all these asymptotes that aren't right. So take the pi over 2 one, shift it to the right. Take the, or negative pi over 2, shift it to the right to 0. Take this pi over 2 and shift that one to the right to pi. So this is pi over 2. This is pi. And then we also need to do one more. So this would be 3 pi over 2, and this would be 2 pi. There we go. Yeah?
Don't you have to do pi over 2 over 2?
No, pi over 2 over b. b is the number in front of x. That 2 out front,
Oh,
yeah, that one's going to affect our stretch. So now we're graphing, and now our normal that goes through 0, 0 is now right there at pi over 2, because everything's being shifted pi over 2 to the right. And then halfway between, we're up here at 2, so it's getting stretched a little bit. And same thing, we're down at negative 2, halfway between. A lot to think about. I think that's the hardest part for tangent and cotangent, is shifting them left or right. It gets a little confusing. Everything else I think is pretty okay. It's not too hard. I mean, there's a lot to think about, but the shifting left and right is the difficult part. All right, so let's go ahead and move on to cotangent. Y equals cotangent x. Cotangent's going to be a lot like tangent, but cotangent, as you know, is the reciprocal of tangent. So everything gets flipped. Cotangent is cosine of x over sine of x. So now we need to figure out where sine of x equals 0 is going to be where cotangent is undefined, and that's where we're going to have our asymptotes. Okay? Cotangent has the same stuff though, like the domain and range and all that stuff. They're going to be a lot alike, except for the asymptotes are different. All right, so the period is still period's still pi. There's no amplitude. Okay? We can stretch cotangent, we can shift cotangent, but here's the key, the asymptotes for tangent. And I think cotangent's a little easier. I said tangent. I think cotangent's a little easier to graph because the asymptotes are going to be at 0, because we know that sine is 0 at 0 when we graph it, right? And then it's also at plus or minus pi over b. Okay? So there you go. The other thing that's different about cotangent is the direction that it goes. Tangent looks like a basic cubic. Cotangent looks like a negative cubic, just its regular parent function. So let's graph. Let's graph y equals cotangent x and see what the parent function looks like. All right, so you go to 0. 0 is going to get an asymptote, x equals 0. And then you also go to pi. Now, when you go to pi and put an asymptote there, there's pi. Okay, you also need a middle part so that you can actually do your graph in there, and this is at pi over 2. And then the cool thing about cotangent is you can go to the right and you can go to the left and exactly the same thing. It's an even function. So you go over here and you do another asymptote at negative pi. And cotangent looks like this. I'm going to go through pi over 2, and cotangent goes the opposite direction that tangent does. So cotangent is constantly decreasing. That's really ugly. I'm going to fix that. There you go. That's cotangent. Okay, so the key thing to remember here would be the asymptotes. Once you got that, you'll be fine. So let's do some fun ones. My kind of fun, not yours. Here we go. Y equals, let's do 2 cotangent of x over 3. We don't like to do thirds a lot, but with cotangent and tangent, it's not as bad as sine and cosine would be. So y equals 2 cotangent x over 3. So here we go. First thing you want to do is, just like tangent, you want to find the asymptotes. Okay? So if there's no shift at all left or right, your asymptote is automatically 0. 0 is always an asymptote for cotangent, because that's where sine equals 0. And then you would do plus or minus pi over b. b is 1/3, and so our asymptotes are going to be 0 and plus or minus 3 pi. And how many asymptotes do I have already? I have 3. That's why it makes it easier too. Because on tangent, you have 2, and then you have to find that third one. It's a little tricky. All right, so we're ready to graph. So it's going to have an asymptote through 0. It will have an asymptote at 3 pi. And it has an asymptote at negative 3 pi. So there's our setup. You'll want to put a tick mark halfway between. You can label that. I don't need you to, because I have the asymptotes. I know that that's going to be 1.5 pi's or 3 pi over 2. It's halfway between 0 and 3 pi. And then we graph cotangent. So remember, cotangent is going to go through that middle point between your asymptotes. This one is being stretched 2. So I'm up here at 2 instead of at 1. And it just makes it kind of a skinnier graph. And I'm down here at negative 2, halfway between also. Okay? And it goes that direction. Now, you might be thinking, cotangent and tangent can be the same graph, right? If we put a negative in front and we shift it, then it will be the same exact thing. And you're right. Were you thinking that? Yes, you were. I thought so. It's like reading your minds. Don't hate me that much, though. Yeah.
For sine and cosine, it's 2 pi over b, but for cotangent, it's
Pi. Yes.
And tangent is 2 pi still? Or?
It's pi over 2 over b for the asymptotes. So tangent and cotangent have a period of just pi, but sine and cosine have a period of 2 pi.
Okay.
Yeah. So let's do this. If you're going to have y equals tangent x, the asymptotes are going to be at plus or minus pi over 2 over b. Okay? If you have y equals cotangent x, your asymptotes, I should write x equals their vertical asymptotes, 0 and plus or minus pi over b. So if you want to write those down next to each other, that's the main thing. And once you have that, then you can graph the rest of it. That's not how you do it, huh? Is that how you do it? For tangent and cotangent? That's the way I do it. It's different. All right, so let's move on. Last part. Part C. Okay, we did the hard stuff already. I was going to switch it and teach it the other way, but I thought I'd do the hard stuff first and then let you kind of breeze through the last. It's like when you're running and you just kind of walk the rest of the way. That's me. Okay, so cosecant and sine and all this stuff. So if we graph y equals cosecant x and we graph y equals secant x, what we're really going to do is we're going to graph sine and cosine instead and then fix it. Okay? So let me show you the basic graphs for cosecant and secant. The graph of cosecant, as you know, or maybe you don't, but cosecant is going to be, it's the reciprocal of sine. Okay, you know that, right? We talked about that already when we did our triangles and stuff. So cosecant is 1 over sine x. Cosecant is also going to be undefined when sine of x equals 0. That's when cosecant is undefined. So here's what basic cosecant looks like. You go to your graph, and I'm going to graph it in red. Well, you go 1, 2, 3, 4. The period's 2 pi, and that's pi. Just like sine, okay? We're just doing the basic parent function right now. Okay? And then what you do is this. You're going to graph sine. Okay? So 1 and -1. We're going to graph sine like this. 0, 1, back to 0, down to -1, back to 0. You should be, fairly comfortable graphing sine by now, I hope. And then what happens is at all of the parts when sine hits 0, that's where you're going to draw an asymptote. No memorizing on this one. You don't have to memorize where the asymptotes are. If you draw the graph of sine, then you know that at the zeros, you're going to have asymptotes. Okay? And then what happens to this graph? You know what it does? It flips out. It does. It goes like this. Has a point at the peak, and it goes along the asymptotes and goes up forever. Down here has a point at the peak, and it goes right along the asymptotes and goes down forever. And it continues to do that. And that's one full period of cosecant. Yeah, you want to see it on your calculator? Of course you do. I'll graph it on the calculator for you. And remember, cosecant is not the same thing as sine inverse. It's the reciprocal. So if I were going to graph this on my calculator, I would do 1 divided by the sine of x. And I hit zoom trig and take a look. See that? It's all those little parabola-looking things. All right, secant's the same thing, but instead of sine, it's cosine. So what you want to do to graph this is going to be wherever cosine hits 0, wherever cosine of x is 0, that's where our function is undefined. Okay? So what I do is I'll go 1, 2, 3, 4. That's 2 pi, and that's pi, and we have 1 and -1. This is just your basic parent function. And cosine, which goes and starts up here, and it's down here. You don't even really have to graph it. If you just see where the cosine would hit 0, you can draw your asymptotes in. Okay? There's another one over here, another one. And then you would just graph it. You'd go to the very top peak, and you'd turn out. It's the opposite of turn up. You turn out. There you go. You like them? They're not bad. Not as bad as cotangent and tangent, I think. Okay, so let's do one now where we're going to change some stuff. Okay? So here we go. Number, what are we on, 5 or 4? 5. Number 5. Let's graph, I don't know, what do you want to do? Let's go y equals 2, whoopsies, we're not doing sine, cosecant of 2x. Okay, now my suggestion to you, and you know you have an option to take that suggestion or not, is to really, are you done? Okay, good job. Is to really graph that. Okay? And you're good at graphing that, right? You're pretty good at graphing y equals 2 sine of 2x. First thing you do is you find the period. Period is 2 pi over b. Period's pi. So I'm going to go like this. And I'm going to count 1, 2, 3, 4. And that's pi. And this is pi over 2. And then I'm going to count up 2 and down 2. Oops. Down 2. Okay. So sine, which would normally go through here at 0, and it would be 0 here, and it would be 0 there. Right? And it would look like that. I can kind of visualize it in my head. It looks like this. Okay? So let's go ahead and let's draw our asymptotes in. Asymptote goes through x equals, the y-axis, x equals 0, and go through pi over 2 and pi. Go to the top, which is at 2, and turn your graph out the other way. And that's one full period, and that's all I ask for. Pretty good, huh? You feel nice and warm and cozy again? Yep. Okay, let's do one more. Let's do a shift, a couple of shifts. You want to shift it? Yeah, let's do a secant. Y equals, well, let's do a negative. -3 secant of x plus 2. Okay? Let's see what that looks like. Y equals negative 3 secant of x plus 2. All right, here we go. So the first thing I like to do is I like to find out what the period's going to be. And the period is just 2 pi over b. b in this case is the number in front of x, which is 1. So period's 2 pi. The period did not change. So 1, 2, 3, 4, 2 pi, pi. All right, the second thing I want to do is I want to shift it all up 2. So I'm going to put in a new x-axis, my pretend x-axis right there. All right, so then I have to think, this gets a little tricky. Let's think where cosine, what the graph of cosine would look like. So here I am at the origin, my new origin right here on this red line. And I need to go down 3 first. So 1, 2, 3. Here's where my cosine graph I would have started drawing it from. My next tick mark, I'm back at 0. My next tick mark, I'm up 1, 2, 3 above that x-axis, the new x-axis. I'm back to 0, and then I'm back down here. Okay? So can you see where the asymptotes are going to go? There's going to be one here, and there's one here, and then I got to draw another one over here. Or I could have gone on this side too. Okay, and then my graph would look like this for secant. There and down here. Everything shifted up 2. Pretty.